Boom. Hello and welcome back to Calculus 1, section 3.5, derivatives of trig functions. We have 6 trigonometric functions, therefore we'll have 6 formulas to memorize. Luckily, those formulas will have some kind of symmetry that we can exploit to memorize them. And again, you have a choice between memorizing formulas or working the limit. Let me show you the limit first. So before we are solving the derivative using the difference quotient and the limit, let's first define 2 limits which we can figure out later what they actually are. So sine x over x as x goes to 0 is equal to 1. And another one where the limit of cosine x minus 1 over x is equal to 0. You don't know these limits because they're not easy to compute, and the method for computing these limits is going to be in chapter 4. So right now I write these limits and you say, cool, okay, we believe you, all right? And then you can go back, and when chapter 4 I'll mention this obviously, and you will pick them up. So now we need these so that we can actually figure out the derivative of sine. So what is the derivative of sine x? That's what we're looking for. Well, we know how to find the derivative using the limit. Limit h goes to 0 of sine x plus h minus sine x over h. And the only thing that we can do, don't forget limit on every line until you use it up. Only thing we can do is expand this using the sum of angles. So you have sine x cosine h plus cosine x sine h minus sine x over h. Now we're going to take the first and the last term and factor out sine. So we have sine x and you have cosine h minus 1, everything divided by h. And I'm going to split this term here as a separate limit because we can break limits over addition and subtraction. So I get cosine x sine h over h. Now, the limit is operating on variable h, which means that x is constant, so we can kick these in front of the limit. So we have sine x times the limit h goes to 0 of cosine h minus 1 over h. Plus, over here I can kick cosine x out and leave the limit h goes to 0 of sine h over h. Now the limit rules told us earlier that this is equal to 0 and this is equal to 1. So I have sine x times 0 plus cosine x times 1, and we just have cosine x. So what we've seen from this limit is that the derivative of sine x is cosine x. One down, 5 to go. I will challenge you to do the same limit if you like this stuff at home and show that the derivative of cosine x is negative sine x. Guys, same calculation. Except now you have a cosine, so you have the formula for cosine and you grind through that. Or you can just memorize that derivative of sine is cosine. That's the alternative. It's like, you know, when you go to the eye doctor, you say, what's better, A or B? A or B, right? So I put limit on one and then I put just the formula on the other and I say, what's better, A or B? And then you pick. Now, What do you have for tangent? How do you find the derivative of tangent? Is what? Yes, you memorized. Secant squared x. Good. How do we get it? Sine over cosine. So the derivative of sine over cosine, and this is what we learned in a previous lecture. It's quotient rule. Yay! F, G, so what do I need? GF prime minus FG prime over G squared. Let's go. Do it. I have cosine squared x in the denominator, cosine x no coughing in the numerator. Derivative of sine is cosine x minus, copy the sine x, and then derivative of cosine is negative sine x. There we go. Beautiful. Cosine times cosine is cosine squared x. Negative sine times negative sine is positive sine squared x over cosine squared x. What sine squared plus cosine squared? Very good. And what's 1 over cosine? Excellent. So what we just discovered is that the derivative of tangent x is secant squared x. What are you going to practice at home? The derivative of cotangent x you're going to practice at home. And you will get negative cosecant squared x. You better get that, because that's what you're supposed to get. So we only prove sine and cosine derivatives using the limit definition, and then the rest we use trig identities to quickly solve these things. What is the derivative of secant x? What should we do? What's secant? 1 over cosine. All right, do this in your spots now. You have your f, which is 1. You have your g, which is cosine. Gf prime minus fg prime over g squared. Let's go. While we're still young.
For Thursday is 8:35. We have. You guys can enjoy this. Not at all. Too bad. That's what I was saying. You have one time sine. That's why I wrote it down. This pair and this pair, you can change them to other functions.
All right. I've seen you guys are doing well, which is great. We have the derivative. So cosine squared x in denominator. Put the cosine x here, and the derivative of 1 is 0 minus copy 1, and derivative of cosine is negative sine x. So what we have now, oh, actually I can do here. Cosine x times 0 is just gone, and then negative 1 times negative sine. We have sine x over cosine squared x. And actually we can simplify this, transform this, whatever. Here, we write 1 times sine x divided by cosine x times cosine x. And now 1 over cosine x is what? Very good. And then sine over cosine is? Nice. So what is the derivative of secant x? It is secant x tangent x. Box. Nice. At home as practice, might be on the next test as a question, like previous questions I asked you to try. The derivative of cosecant x is negative cosecant x cotangent x. Now, just in time, I am going to write all 6 trig derivatives in one spot so that we can look at them and compare them and see the cool way to remember and memorize this stuff. Or you can do the limit. I'm going to write the same thing. The derivative of sine x is cosine x. The derivative of cosine x is negative sine x. The derivative of tangent x is secant squared x. The derivative of cotangent x is negative cosecant squared x. The derivative of secant x is secant x tangent x, and the derivative of cosecant x is negative cosecant x cotangent x. All of them in one chart. Can you make an observation? All right sides are negative. So the derivative of co-functions is negative. Right? Cosine, cosecant, cotangent, right? So if it's a co, it's a negative. Cool. What other observation you can come up with? It's tough to see it, but oh boy, that helps. All right, talk to me now. What I write down there? Trig, what does that mean? Nice. Now in English, yeah. Can you spot what I mean by this? Okay, let's go. 1 minute left and then another 10 after that. Yes. Nice. And? No. No. Sine and cosine? Sine and cosine? Nope. What's the next pair? Tangent and secant. And? Nice. All right. Look at these pairs. Try to find a different combination. If there is a tangent present, there is a secant present. You see this little block over here? That's only secants and tangents. That's only cotangents and cosecants. And these guys are all sines and cosines. The trig pairing never escapes this. You cannot get the derivatives working and then jump the ship from one pair to another. When you see a problem that contains mixture of these things, you have to use identities to fix it, otherwise you're doomed. So trig pairing is in effect here. Sines with cosines, secants with tangents, cosecants with cotangents. And now, the grand finale over here. Look at the form. The tangent, the secant squared, the cotangent, the cosecant squared. Secant, secant tangent, cosecant, cosecant cotangent. You see that the form per line, per row, the form is the same. All of the cos are negative, and then you have the trig pairing. So all of that stuff helps you in determining. So technically, if you learn this side, you know immediately the other side. Because you know that you have to follow the pairing. You know that the other side is all negatives. Right? And you're technically copying the left with the functions from the right. Are we all bueno on that? Which problem are we going to do now? Which one? Equation of the tangent line. Find the equation of the tangent line at x equals, let's say, pi over 3, good enough, for f of x equals 3 cosine of X over 2 is good? Yeah, x over 2 is good. So x over 2 is the same as 1/2 times x. And you know what to do with a. Because you know what you did with a for ease. What did you do with a for ease? What did you do with a for ease? Where was e to the ax? What did you do with a? Plug it in front, yes, good. So now you have this 1/2 x. So x 1/2 goes in front when you do the derivative. And remains inside. All right, let's see what you get. Remember the same procedure. Take the derivative, plug in pi over 3, get your slope. Plug in pi over 3 in the function as is, get your y. Use all of the values to get the equation. It's 1, 2, 3. We have only about 3.5 minutes left of the class, so I have to start solving this. So we find the derivative, which would be 3 times 1/2 negative sine of x over 2. So it's negative 3/2 sine x over 2. That will be the derivative. Again, I'll write it here. The derivative of, let's say, sine ax is going to be a cosine ax. So this ax remains as the same thing as it, you know, a e to the ax. You didn't change the the exponent. So you don't change the argument either. Great. So I have the derivative function. Slope m is when I plug in the point, which is pi over 3, into the derivative. So that's negative 3/2 sine of, in this case, 1/2 times pi over 3. So slope is negative 3/2 times sine of pi over 6. And what's sine of pi over 6? Very good. That is equal to negative 3/4. So I have the slope as negative 3/4. Now, y is f of pi over 3. So now we plug in pi over 3 in the original function to come up with y. That's 3 cosine of pi over 6. Now that is root 3 over 2. And we have 3 root 3 over 2. So what do I have? I have slope, which is negative 3/4, and I have a point, pi over 3, comma, 3 root 3 over 2. And now we have to find the line. Yay. Y equal mx plus b. Y is 3 root 3 over 2. M is negative 3/4. X is pi over 3. Well, at least something cancels. Plus b. So how much is b? B is equal to 3 root 3 over 2 plus pi over 4. My 3 is canceled. And you can do the common denominator here. So everything is over 4. So that's 6 root 3 plus pi. So what's the equation of the tangent line? At x equals pi over 3. Equation is y equals negative 3/4 x plus 6 root 3 plus pi over 4. You can get the decimal for 6 root 3 plus pi over 4 if you really want to, but no one cares about your decimals. This is just fine. Leave it as a full answer. I know it's weird to look at the line. You are used to 3/4 x plus 1, but right. So that's it for this time. On Thursday, if there is Thursday, depending on the apocalypse tomorrow, let me just say bye.